Okay, yesterday we have created a free-tier Snowflake account and we have gone through all the available options here. So today I will walk you through the Snowflake architecture. How is it different from other databases or data warehouses? I will walk you in detail. Let me open a notepad. So Snowflake architecture. Snowflake is we can say Snowflake has a hybrid architecture. So I will tell you what is hybrid, what is its combination. Generally, the traditional databases uses shared disk architecture. I will tell you what is the shared disk architecture. Traditional databases uses shared disk architecture. So shared disk means we have one central data repository. One central data repository. So it means that the data will be stored in one location, and on top of that there are multiple uh, warehouses or virtual machines, we can say. There are multiple access systems or the compute engines, one central data repository and multiple compute engines sharing this data repo. So there is only, let us assume that we have a Google Drive account, we have photos in that. So in the same link, we can share with multiple people. So, but if there is any issue or we are running out of storage in the main cloud, I mean, whoever is owning that cloud, whoever is owning that Google Drive, if he is facing some issues in accessing that, everybody will be able, everybody will be facing the same issue. I mean, whoever has provided access or whoever with whom with whomsoever we have shared those photos, everybody will be facing the same issue. So this is the drawback of shared disk architecture. Single point of failure. Single point failure. If something on the data repository fails, something on the central data repository fails, so there is no other backup or there is no option available to access the data or do something. So if we want to, whenever we talk about data, two things comes hand in hand. One is storage and the other is accessibility. Let us say our phone has a lot of memory. We can share, we can store photos, files, all kind of things. We can store it. But as the size grows, let us our phone has 100 GB, and if we are almost occupied with 90 GB, the phone operation will become slow because the memory is almost occupied. So the space is reduced. So for performing any operation, it will take some time. Same happens here. So as the data grows in this kind of architecture, as the data grows, if we want to increase the storage, the compute capacity has also to be increased. Let us say our phone has some 256 GB and our RAM is only 1 or 2 GB. That won't support. Still we have less performance only. If there is more storage, but still the less RAM. RAM is the place where the computing happens. If the memory is huge, but the RAM is less, the performance will not be good. So in this shared disk architecture, if we increase the storage, then compute also has to be increased. If we increase storage, then compute also has to be increased. So then on this model that works that way. If we increase the storage, compute also has to be increased because we cannot scale them independently. Scaling is the term used for increasing the size or increasing anything. Increasing, we can use the term scaling. So for if we increase storage, if we want only storage to be increased, we are okay with 1 GB or 2 GB RAM, but we want more space. So that is not possible in shared disk architecture. They are tightly coupled. They are like linked, cannot be increased. One can be increased, other cannot be decreased. It has to be happen parallelly. So only if we want storage, then also we have to pay for the increased compute. And otherwise, if we want only the compute power but not the storage, we have to pay for both of them in this kind of architecture. Even if you use or don't use, they won't care. You have to pay for both of them. And then this latest the data warehouses, cloud-based data warehouses, cloud-based data warehouses. Not all, only Snowflake. I can specify only Snowflake because other cloud architectures also sometimes follows the shared disk only. Snowflake data warehouse. Before coming to this, we have shared nothing architecture. In this shared nothing architecture, we have so many data repositories attached to so many compute engines. I will show you the diagrams as well. Shared nothing is many data repos, many data repositories. Here it is only one central data repository, but in shared nothing architecture, it has many data repositories, which means that each copy is stored on each compute machine. So let us say I have 10 laptops. Each of the laptop is holding the same data, and all these 10 laptops have the same data, same compute, everything. So if we want to increase the power only for one laptop, we can do that. So that is nothing but shared nothing architecture. So if data in one of the laptop is destroyed, still we have 9 more laptops and we can do anything on those 9. Many data repositories and many compute engines, many compute engines which runs parallelly. So as we have 10 machines working parallelly, if we distribute the workload, if we are running any query, then all these 10 computers will work simultaneously in getting the data, and it retrieves the results faster because so many people are working on the same thing, so that the time in completing that works will get when completing the work will get reduced. Same happens here. In shared nothing architecture, the data copy is stored on all the compute machines. It behaves like all the compute machines have the same data and all of them are working parallelly to complete a certain task. So in this process, we can scale storage and compute independently. Storage and compute can be scaled independently. If you want only storage to be increased, you can increase that. Or if you want only compute power to be increased, you can increase that without paying for the other. If you increase storage, only you can pay for storage. If you increase compute, then you can pay only for compute. Whatever you use, pay for whatever you use. Nothing extra. So this is a shared nothing architecture and this is a shared disk architecture. What Snowflake does, it is a combination of both the architecture, shared disk and shared nothing. Hybrid of shared disk and shared nothing. So what it means is, what is the resemblance between shared disk? What features of shared disk the Snowflake uses? Snowflake has a, sorry, what features of shared disk architecture does Snowflake have? So coming to this shared disk architecture, it is a central data repository. It will take this feature from here. Shared disk architecture. This is the architecture is the most important thing in any interviews. They will definitely ask this question. What is the architecture of Snowflake? What is its different between the other things, other databases or data warehouses? So the feature it takes from shared disk architecture is central data repository. Central data repository. What it takes from shared nothing. What feature does it acquire from shared nothing? It acquires independent compute and storage. Independent compute and storage. So from each of these architectures, it will take one feature and then combine it with the other. So we have central data repository. Even though there is a failure in one of the systems, it it will be like, even though it is a central data repository, on the background how the data is stored or distributed, it will act like each copy of the data is stored on all the compute engines. Even though there is a data in a central data repository, it is not a single point of failure. We still have the backups because it is a combination of both the things. That's why we can scale compute and storage independently, like a shared nothing architecture. Like shared disk architecture, we have a central data repository where all the compute engines can access the data. So I will show you the diagrams now. Shared disk architecture. Let me go to images. See, this is an example of shared disk architecture. One second. What is the best thing? See, in the shared disk architecture, all the data is at one place. These are the compute engines attached to this data. There are many compute engines attached to this data. But if we want to increase this storage, we cannot increase without increasing the compute engines. On the other hand, shared nothing, the storage is separate and each storage is associated with a compute machine. Each storage has its own compute machine. So if we want to increase this one, we can increase without affecting this because the workload is less. But on the background, it is like, it behaves like, though it is a shared nothing architecture, it behaves like all the data is available in A box, all the data is available in B block, and everything is available in C and as well as D. The behavior will be like that. But the background architecture is, it is combination of shared disk along with shared nothing. It has features from both of the data, I mean, both of the architectures. That why it is called as a hybrid architecture. This is one part of the architecture, and we have more to add on to this. Snowflake has this hybrid architecture along with three-layer architecture. Along with three-layered architecture. So Snowflake has three layers of architecture. One is storage layer. Storage layer is about which will store the data. So now our Snowflake account is hosted on AWS cloud. So all our data is sitting on the AWS cloud S3 bucket. But we won't be able to go and see which S3 bucket is holding our data, which S3 account is, or which AWS account is holding our data. That all we are not able to access. Nobody will be able to access that part. We will be able to access data only through the SQL queries by writing on Snowflake. Uh, and then that is how the security is provided. If we are able to access S3, like whatever the views, tables, stages, whatever we create, if they are accessible on S3, the data will not be secure. That's why it is like, and also Snowflake is a software as a service. So we don't need to worry about what is happening on the background, how our data is stored, how we are getting it. We don't need to worry about that because that is software as we are using Snowflake as software as a service. So we don't need to worry about that. Everything will be taken care by Snowflake, the security, how it will store, how it will get, all these things will be taken care by Snowflake. This is the storage layer where the data is stored. We won't be able to access this at any point of time on the S3 bucket or the cloud. Next comes the query processing layer. Query processing layer. Query processing layer is like compute power. It is a compute power. If we run any query, So let's say we have a table with the 10,000 records, and if we want to see all those 10,000 records, we will submit a query to Snowflake. Select star from table. So on the background, the data will be distributed. The data will be distributed on the background into various storages and nodes. So we need to get all of it. So whenever we submit a query, Snowflake does some background work and it will display results to us. It won't tell what it is doing in the background. It will just display the results. So that processing all happens in this query processing layer, which is nothing but the compute, which gives compute power. So in Snowflake, the compute power or the size, compute size or the compute power is handled by a concept called virtual warehouse. Virtual warehouse. So as we have talked some time ago about our phone RAM, it is 2 GB, 3 GB RAM. So similarly, in virtual warehouses, in Snowflake, we call it as virtual warehouse. Same, it is same as like RAM only, but the terminology is virtual warehouse. Here also, we are not going to have any physical machines or the computers. We are just going to buy this on the cloud. Our cloud is our Snowflake account is hosted on AWS. AWS will have some virtual machines like EC2 instance. Uh, some it will have EC2 instance. E- EC2 instance will provide the compute power. So, but we won't be able to see the what is happening in the background. I will show you how to create the virtual warehouses. We have different sizes like our t-shirt sizes, small, large, extra large. We have so many sizes based on our data size and query execution. We have to select the suitable size. This is about the query processing layer. And there is storage, compute, query processing, and there is one more layer, uh, storage, query processing. Once again, that is acts as a brain of Snowflake.
Service layer.
Yes, correct. Yeah. This is the service layer where it will take care of most of the activities. 80% of the activities will take care in the service layer. It takes care of the security. It takes care of security. Even in the query processing also, how the workload should be distributed. That all will be decided in the service layer, the access related things. When I say access related, if whenever a new employee joins our organization, we have to provide him access. So all those kind of things, service layer will take care of that. In one word, we can say it as service layer is the brain of Snowflake. So these are the different layers and the architecture in Snowflake. And Snowflake has massive parallel processing capacity. Massive parallel processing means many compute nodes will work simultaneously to give the results faster. This is called massive parallel processing. And it is a columnar data warehouse. Columnar data warehouse is nothing but the data is stored in units of columns. Yesterday, I have shown you the row-based architecture and column-based architecture. Each row will be stored as a column. Not exactly each row will be stored as a column, but some set of IDs which are sorted or a group of IDs or group of names, they will be stored in a single unit, which is a column. So the data is stored in a columnar format. So this is the overview of the architecture, three-layered architecture as well as the hybrid architecture. Because of this architecture only, the Snowflake has become so famous and it is extensively used in many applications. In data engineering, data science, it is used by analytics. In many applications, we can use it. So this is also cost efficient because we are paying for only what we are using. It has a combination of both architectures. That's why we can pay for only what we use. Even in case of virtual warehouse also, if we select small size, we can pay for only small. and how much seconds or minutes we use, only based pay for second billing. I mean, or whatever we use, only for that amount of time or that size of the warehouse we have to pay. This warehouse, whenever it's required, we can resume it, and if it is not required, we have to suspend that. We can set these policies automatically also. We have policies while creating a warehouse, when it has to be resumed, when it has to be suspended. We can define all those options while creating the virtual warehouse. I will cover that in detail later. So this is the architecture. Now moving back to Snowflake. So basically we use admin role. Account admins will create the database roles. These are the one-time objects required to be created. Database, it is like at the start of the project, we need to create we have to design our data warehouse. We have to define our data modeling and then create the tables. That is like one-time activity. Tables, we can create tables every day, we can create tables, but the database, in which database our tables has to be present, that is one-time decision. Like at the start of the project, we'll define. So account admin will create the database. Account admin will create the virtual warehouse also. Will be different sizes of virtual warehouses are created by the account admin. But while providing access, they will provide only some sizes of virtual warehouse. They might provide a medium, large, extra large. Based on our requirement, we have to select. So now we'll create a database of these are all already existing. This Snowflake, this is one of the database. In this, we have various schemas. These schemas holds different types of objects, views, functions. So whatever it is, while querying the Snowflake, we have to query it like this. Select star from. Basically, we use SQL only. In order to get data out of the Snowflake, we have to use SQL queries. There is no other way to get the data. So select star from. First, we have to specify the database name. Database name is Snowflake, and the schema name is account usage, followed by the view name. Here, this schema is holding only the views, so I'll be accessing only views, access history. There might be a lot of data here. I will just limit it to 100. See, it has some details like query ID, start time, runtime. This is basically access history. So whatever we have done till now, all those history will be stored here. It's just wanted to let you know that this is how we have to access the tables which are already in Snowflake. It might be any object, or the views, tables, pages, anything. We can access it like this: database schema followed by the table name. So this is a directly a database, but the next one, this is a data share. This symbol is also here. If you look at the source, it says share. So even from the share also, we'll do the same operation. Select star from Snowflake sample data, which is our database. Inside that, it is giving options. Inside this, we have so many schemas. We can select any one of it randomly. And then here it is populating the table names. I can take customer table. This also has a lot of data. I will just take the sample data. So whatever it is, we have to query it like this. Whether it is a share object or a database object, whatever it is, we have to query it like this. So as I said, Snowflake is a columnar data warehouse. Instead of doing select star, it would be, see, now we are selecting only 100 rows. It won't be a big problem. But in real time, the table will be so large. We have a lot of columns and we have so many joins. In those cases, we should not do select star. Instead, if we want only these two columns from this table, just specify those two columns. See customer SK and see customer ID. So that way we can optimize our queries. If you want to look at the query execution plan, here is the query ID. I will show you now, but I won't explain much here. Later, I will explain once we cover all the topics. So when we do select star, here it is giving the profile overview. Total time execution is 371 milliseconds, out of which 20% of time is utilized for processing, 40% for remote disk input output operations, and 40% for initialization. Now I have retrieved only 100 rows from the table. In order to retrieve those 100 records, it has scanned 60% of the table. So the table has, let us see how many records are there in the table. This is in MB. How much MB it is scanned? 15.74 MB is scanned. There will be partitions. When I say partitions, let me go back to this worksheets. So I will do the count of star from this table. Count of star will show how many records are there in this table. It has 1, 2, 3, 100 million records. It has 100 million records. So out of these 100 million records, we are getting only 10. Now we can go back. These 100 million records are divided into 221 partitions. We have not done anything. Even in the future also, we are not going to do any partitions. Snowflake will automatically do that. If the data size is less than 1 terabyte, Snowflake will automatically optimize the data and store it in an optimized way. But what our main concentration should be is, see, the count will execute only the metadata. It will not query the actual data. Let us run this, select star. One second. It has not given because there is a concept called cache. The frequently, I mean, whatever the queries we run, the data will be stored for next 24 hours. And it won't again scan this whole table. It will give the same result. That's why it is not giving the query plan again. Okay, I'll show that later, the query execution plan. But what I wanted to say is it has total 221 partitions when I looked at the query plan. And when I fetched limit 100, it has scanned only one partition. So our query should be in such a way that it should be the minimum number of scans should be partitioned. Our query should scan minimum number of partitions as much as possible.
Yeah, you just click on the show more on the right side corner.
Yeah. This is the, profile of the data.
Okay, results. Okay.
Yeah. This is the profile of the data. I think I have the window open. No. Let me run another query. So if we run the same query for the second time, it will get the results from the cache.
Just change the limit. Why don't you just change the
Yeah,
limit?
that's what I'm doing. Sample data. Now, if you see here, this all we have explained. It is total time taken is 559 milliseconds. Input output operations is 60%. Initialization is this much. But our point of thing which we have to focus is it has this many partitions. Let us say this table is holding again 100 million or some amount of data, which is a huge data. We are getting only limit 100. So it has scanned only one partition. This is good. because we have not applied many much logic here. We are just taking the sample data of 100 records. But in real time, when we want to generate a query which will give some insights about our business, that time it will have so many joins, so many tables, around 10, minimum 10 tables should be joined, and we'll have hundreds of columns. During that time, our partition scan should be less. It will happen. This number will get reduced based on our optimization of the query. So if we do select star, while with those 10 tables joined, the partition scan will be more. If we do only select 2 or 3 columns, only required columns, the number of partitions scanned will get reduced. So by running and executing the query, looking at the query plan, we will be able to optimize it. Just give me a minute. I will connect the charger. Yeah. That is how we have to look at the query execution plan. After our course, I will again walk you through this query optimization. But now go to this worksheets again. So this is the sample data we have queried. So now if we want, by default, this is my own account. I am the root user. I am the admin of this account. But in whenever we join organization, we are not the root users. There will be only one account and there will be multiple users. So I have to give them access to the tables or the relevant databases, virtual warehouses, all that. So first, if we want to select any of the any of the roles, we have to select it from here. If we want to switch the role, just click here. It will select that. Or otherwise, if you want to do it through a query, then select, sorry, select organization. Now it is already organization admin. No, current account admin, sorry. Use account admin. Object does not exist or cannot be performed. Is that the name? Use account. And also one more thing
Implementation role.
here.
Hmm.
Sorry. Role.
Role keyword.
Yeah. Use role account admin. See, if you see here, it is automatically switched to the account admin role. If we want to switch to other thing, we can do that. Do you already have experience with Snowflake?
Not exactly, but I was learning on my own, and
Okay.
I just had some idea. Just
Okay.
looking.
Okay. Nice. Okay. So if we want to switch the roles, we can do it like this. These are the roles. By default, it will have the public account. Whenever if we add a new user to our account, it will by default give the public role. Even though if we don't give anything, it will by default have the public role for that user. So with this account admin, I'll go back to account admin and create a database. Uh, so if we want to know in which role we are using, we can do this. Select current role. We can look from here or also through the query. Select current role. Yeah. So it is the current role. You can run through query or through the UI options. Now our role is set to account admin. I'm going to create a database. Create database. I will name this as test database. So now remember that we are creating with account admin. So database is successfully created. We'll refresh this and see. See, now it has the test DB. Previously we have only two. Now we have test DB. Or you want, instead of UI, if you want to see through queries, you have to do it like this. So show databases. We have three databases and it has all the options. How is it created? Which role, by which role it is created, like that. We have all the details here. You can go through this. So we have created database. So inside that database, we can create a schema. So as you have seen here, for every Snowflake table, it requires database followed by schema followed by table. So now I will select database. If you have already selected database here, you don't need to write in the query again. Select, as we don't have any tables here, okay, it has. But this information schema and public, these are available in both of them. Still, it will give the result from here only. Classes, place name and editor. Okay. Select star from this one. I will limit this again. What type of object is this? View. Let us take another one. We haven't created it. This is information schema. It will basically hold the metadata of everything. Right now we don't have anything. That's why it is giving empty thing. I mean empty table. So database name. Just we have the table structure, but no data in it. So here what I wanted to tell is here we have already selected database. So while running the query, if we don't select the database, still it will give the results from this database only. Sorry. Now, the same result. It has given the same result with the test DB, without the test DB, because we have already selected here. Same with the schema also. Now the default schema is selected as public. If we have any other schema, let us say I want to select, it will display. See here, this is the database. Here it will have two options. Public is by default, it will come, and I will want to select information. Now I will remove this information schema from here. Yeah, this is called context. If we have already set the context, we don't need to specify the database and schema. From default, it will take this table. If we don't specify database and schema from the default set context, it will execute. So though we have set the test DB and information schema here, we want to run it from the other database. We have to specify the fully qualified name. This is the fully qualified name we can say. If we specify database and schema, that is called fully qualified. Next, inside this database, we'll create a schema. Create schema. And schema is, I will say test schema. So it will get created inside this. So here you can do it like this, or else if you want it, if you want to write it through a query, use database test DB. You can do it like this. First you have to run this. And next, if you want to do whatever activities you want to do inside this, you can do that. Now I want to create a schema. Now schema is created successfully. Let us see if the schema is available or not. Let me refresh this. See, the schema is also available. Inside this schema, we should have tables, views, and there are a lot of objects in Snowflake. I will tell you. Now we'll create a table. Create table. Some student table. We'll create it with ID as integer, and name as varchar. So in varchar, if you don't specify the length, it will take the maximum length, which is 16 MB. So in each column, it will fit the maximum of up to 16 MB. So we don't want that much of space for just a name. I want to restrict these characters to 256. It will accept till 256 characters. I'm creating this table. In Snowflake, I don't be focusing much on the SQL part. I'll just see for how we can access or how we can create. No, I will insert the data into this. Insert into student. ID is 100 and the student name. We can insert as many records as we want. I will insert 3 or 4. ID John. I will execute all these. Next, okay, we have to provide values. So the 3 rows were inserted. Now we'll do select star from this. Select star from student. So all the 3 rows are inserted. Now we look at this query execution plan. It won't be much, only small data. So total partitions are 1 and available partitions are also 1. Since there we have only 3 rows. Yeah, this is how we need to create a database schema and table inside that. Now we have created all of this with account admin role. Now we will switch to the other role and try to access these objects. It has switched to organization admin. Now we are not able to see test database here. Let us see with the other roles as well. Security admin. So with the security admin, we are able to see database, schema, and table. And now we'll run the query also. Are we able to access it or not? See, it says object does not exist. Let me refresh. Okay, here we haven't selected anything. No, we will query this. Ideally, if it is shown here, it should be able to access test db comma test schema dot student.
You need to check select the warehouse.
Yeah. See, warehouse also we have to create because only for some high level roles, the warehouse will be provided by default, which is a compute warehouse of extra small size. With organization admin, We don't have that warehouse, and no warehouse here as well. First, we'll create a warehouse with the account admin role itself. Or we can grant access to this warehouse to other accounts through account admin only. Using the account admin, we can provide that access. Grant usage on warehouse. We have to provide the warehouse name, which is compute warehouse. To role. To which role we want to provide. I will provide all of them. So, organization admin. Next, security admin. This role level access we won't be taking care of in the real time. There will be a DevOps team. They will take care of these roles. Our job is only with the data. But still we have to know how this works. And user admin. So we have provided access to the warehouse to all the roles we have. Now we will switch to the other role. Select a warehouse. Now we have got access to the warehouse as well. And then do select. Let's what is this? Test DB does not exist. Okay, let us refresh this. Again, I will go to account admin and provide access. Grant select on database test DB role. To which role we need that? I will provide access to all the roles available. Admin. Grant select invalid. So we do select on tables, not on the databases. That's why it has given error. I have granted all types of access on the database, like a creation of schema, creation of table, creation of stage, whatever objects are supported in Snowflake. All that I have given access to user admin. Similarly, I will give for other roles. Security admin, system admin. And also to organization admin. Now we will switch to any of the roles. Warehouse is already selected. Now do select star on the student table. I think we need to provide access to schema as well. I will do select all this. Select all on schema. Schema name. But first, let us test for user admin only. Again, even if we provide access to schema level, we have to provide access to the tables also. Let us see user admin. Select user admin. Warehouse is already selected. Now run this query. See, we need to explicitly provide access to the table as well. Grant. Now I'll write select. I don't want the update or delete access from the table to other roles. Grant select on table name. We'll set the context, and we will select to role user admin. This executed. Now we'll switch to user admin. Warehouse is selected. Select star from student. The context is already set here. That's why I'm writing just the table name. Now we have access to the data. This is how. So usually in general, the grant access will not be provided for these roles. These are the default roles. They will do some customizations to this. And apart from that, they will create a new roles. We will do that in tomorrow's section, creating new roles, adding new users to our account. We'll do that in tomorrow's class. Any doubts till here? Okay. Sorry.
Nothing much.
Okay. We can continue. This one more thing. Tomorrow weekend, so is it possible to have class for all of you?
Yeah, it should be fine. For my end.
Okay. Yeah, we'll continue at the same class if it is fine for all of us.
Yes, fine.
Yeah. Okay. Stop recording.